Alright, let's do this. Let's finish this thing that we started a little while ago. Restream chat. Come on, where'd my mouse go? Okay. This light is so bright. There we go. So, restream chat gets smaller. Chat is ready to display messages. Make it smaller still. And let's set it up to be transparent. So background opacity, like that. Message opacity, bam. Window on top, and okay. Right. Back to chat. Cool. So now where was I? You're gonna start. Great. Cool. So we got the thing, and so we have the map renders, and there's a line on it. So our next step, this was basically just copied from the getting started thing from, what was it? Okay, layers, new line layer. So now the next step is finding the data for airplanes. Live airplane position, live airline positions, flight tracker. Freight metrics. Cool. So we have that. Which aircraft are visible? Common. How to use flight stat. For all flights from a designated airport. How do we get just all of them? Flight radar 24. Flightradar24.com. I'm trying to see if we can get live positions of all the airplanes currently up. So data, search airports, airlines, aircraft. Close. I wonder if there's a way to get access to all of them. Data services. Okay, so is there really no like just easy live flight tracker API? No. Live airplane position API. There has to be an API for this. Free real-time flight tracking data via an API. Okay. Aviation data provider. Co-op of unfiltered flight data. Cool. That looks Open Sky Network. Yes, that looks promising. currently tracking many of these guys. Our live API comes with Java and Python bindings, but it can be used with any language that supports JSON-based REST APIs. Wonderful. Okay. Get your API key. That looks promising. Ooh, that looks sexy. Data downloads an API. I agree. In addition to the browsable map, blood donations, querying live position data, all aircraft. Okay, so let's see, what does this return? No API key. So within nautical miles of point located at latitude, that could be useful. That way we would be getting less stuff. Okay. How do I get an API key? Let's see this one first. Open Sky, state vectors, live API, information is provided, REST API. Okay. Hey Eric, I'm pretty sure you shouldn't be watching this while you're working, although I do appreciate it. Bounding box covering, okay. Check Telegram from Alex, let's see. What is Alex saying? What? Where is commenting off? Commenting should definitely not be off. I can't see. Why did I point a light at my face? Alright, so that you can actually see me. So if we get all state vectors, well, then we can do stuff. Okay, let's see, how do I need an API key? Docs. No, do I just make a request? So let's try that. So we're gonna make a fetch request to, where is it? Where's our localhost? Okay, I'm gonna move this to the end here and say fetch blah slash API slash state slash all. That sounds how would you say that? Sounds unwise, doesn't it? But let's see. Then console.log promise pending. Oh, cool. Course, body used, headers, URL, status 200, body, readable stream. Okay. So then response, and we say res.json, then console log. Now this one's gonna hurt, I think. Promise pending, bam. Oh, and we got an array of 6,000 things. That's useful. A8808C4 United States, blah. Wow, that totally worked. The iOS Twitter app, I think that's Periscope. Let's see if I can enable commenting on Periscope. Broadcasts. I don't actually know how to enable commenting. I'm not good with the Periscope. More options? No, I'm not. I don't want to report myself. Full screen theater mode. Yeah, I have no idea how to do this, so I will ignore it for now. But we have our data set, and that worked surprisingly fast. So here's what we're gonna do. We're gonna load our data here. Initial view state, data is not defined, yes. We're gonna take out the layer. And let's go check what kind of other layers WebGL supports. I think a WebGL API reference, composite layer. What's a composite layer? Composite layer is a subclass of the layer class, customize various layer lifecycle methods. What the hell are layer lifecycle methods? Layer rendering cycles, initialization, updating, should update state, rendering happens during each rendering cycle to draw the layer. Okay, we can do that. We can deal with that later. Contour layer, GeoJSON, grid layer, hexagon layer, icon layer, scatterplot layer. That looks like what I'm looking for. Twitter message from Kiran B. Wow. I think responding to Alex let's see, Kiran, reply me. Oh god. Okay, I will look at this in a bit. Okay, following you to. Okay, so if you can, Kiran, if you can give me some more info on what you're trying to achieve, and if you provide a data set, we're gonna do it tomorrow or the day after. How does that sound? And describe. Cool. Okay, close that. Now let's see, how does the scatter plot? Now let's get the data first, and then we're gonna deal. Okay, the light is kind of messing with my eyes, but where are you? So scatter plot layer is gonna be next. Hey Julian, how was your work? Or I think you said you were busy, you were doing stuff as well. So const layers equals blah. Now let's make a component in mount. Yes, so we're gonna build a thingy. What should we call it? Fetch data, which is going to look like this. Const so fetch data, which does what? It says fetch. Oh, let's use d3 JSON because we can. And we stop this guy and say yarn add d3, and we import asterisk as d3 from d3, so that's gonna make our life a little bit easier. Yarn start fetch data d3.json from the where was I? Get this d3 JSON blah, then let's see, then console log. Okay, and we run that on component did mount. We're gonna say this.fetch data, and it's going to look like this. So this is now a automatically bound function to our component, and when that restarts, gets a bunch of data. Now we gotta figure out how to display this data. So what are we gonna do? State airplanes is an empty array, and here we say get states. Okay, so this is kind of annoying. I'm now typing behind the chat, and that was not the best idea. Also, why is prettier not prettifying shit? Okay, we got that. Bam. So we now have state. It's going to re-render our thing, I think. And I'm not yet sure if re-rendering is the right approach, but we're gonna try it. Now what does our layers, let's see, new scatter plot layer with an ID of scatter plot airplanes, and data is this state airplanes, and we say pickable is gonna be okay, let's make it true. Data and viewport. What is a viewport? Oh, the viewport is, I don't know what the viewport is. Opacity 0.8, radius oh, okay, I see what's going on. Radius min pixels is going to be 10, radius max pixels might as well be 100. So we're using the scatter plot, but it's not really useful. We're just using it because we can. So coordinates are that. So for get position, we're gonna take the D, and what does our D look like? Where are we? Or let's look at it here. Yes, you can go to gaming. I want to see what it actually returns. Request time response. States is an array. The states property is a two-dimensional array. Each row represents a state vector and contains the following fields. Index. Okay, so string, call sign, origin country, time position, last contact, longitude, and latitude. So we're gonna return d dot longitude, d dot latitude, I think. Or actually, let's do it this way. Let's comment all of this, or rather, let's remove all of this. Oh, come on. Remove all of this stuff and console log this dot state dot airplanes, and let's see what kind of data we actually have, what the shape is. So an array, oh, and these are all arrays then. Got it. That's gonna be kind of annoying to deal with, but we can do this. Actually might be easier to parse it. Yeah, let's do some parsing. We're gonna, in our JSON function, we're gonna parse it all into objects because that will make our life easier here. So longitude, d dot latitude. Is it longitude latitude or latitude longitude? D dot latitude. Okay, go back to WebGL. Get color. We can return the same color for everything. The returns 255.140.0, and on hover okay, we're gonna deal with that some other time. radius, default 1, get color. Okay, so this should now be drawing a scatter plot, and here we're going to states.map, and we're going to, for each D, we're going to return this. Let's see, back to open the from blah, and let's see, call sign is D of 1. What's it complaining about? Okay, on line 37. Okay, there we go. Call sign is the blah, then longitude is D of 5, latitude is D of 6, and we can also take, what are we gonna do? Let's take velocity, because that sounds like it's gonna be useful. Ooh, altitude. Altitude is D of 13, and origin country, let's do that as well. Origin country is D of 2, and on ground boolean value, which indicates if the position was retrieved from a surface, velocity over ground, true track, vertical rate, sensors, geoaltitude, squawk, whether flight status indicated, special purpose, blah, position source. Let's see, what else can we say? Okay, so now let's see what happens when this renders. Look, airplanes showed up. That's cool. So we can now see all of the airplanes in the world. Neat. Now let's make it so that these airplanes are a little smaller. So radius min pixels, and we're gonna say get radius is going to return, let's say 2. No? Okay, that's just my... Why is that not working? 5? So when the pixel... Okay, so now we can see the airplanes. That's cool. Okay, so all the airplanes are there. Now the next thing we need to do is make them move. So I'm gonna start a timer, and it's going to keep requesting these things. Does it give us a direction? No, it's just the current. Anonymous are those users who can only get the most recent state vectors, i.e. the time parameter will be ignored. Can only retrieve data with a time resolution of 10 seconds. This means the API will return state vectors for time. Okay, so only every 10 seconds can we get, which is pretty annoying. Okay, that's our own time vectors, flights in time interval, flights by aircraft. arrivals by airport, departures by airport, track by aircraft. Intro and data structures. So what would be really cool, okay, so we do have directions, which means if we have directions, then we can fake movement between how often we can, because we can only request responses every 10 seconds. So let's try that. So we got that component did mount fetch data, and then we say fetch data is going to set timeout this dot fetch data in 10 times 1000. So let's see. I'm gonna, so we have these guys, and now in 10 seconds it should refresh and give us new positions, although I'm not sure how we're gonna know that. Let's see, console log fetching data, and let's change the zoom to be 5. Okay, so we will see if in 10 seconds they actually move. So I'm gonna just have to wait for 10 seconds, and we're gonna see, yeah, they moved. You see that? They're gonna move again in about 10 seconds. They move, yay! Okay, so that works. Great. Now the next step, oh, I should probably commit this. So let's see, git our cd documents, random coding, WebGL, airplanes map, git status, git commit -a -m, and we're gonna say, what are we gonna say? Render airplanes as dots every 10 seconds. Cool. So we've got that. Now we need to fake movement. So we're gonna look at the response again. We have call sign, time, position, longitude, latitude, on ground, velocity, vertical rate, altitude, position, source. How do I get... clockwise from north, true track in decimal degrees. What is true track? Okay, let's try true track, and let's try faking their movement. So true track, d of, what was it? Clockwise from north can be null. Let's see, true track 10, d10. So for each airplane, how do we make them move? And how do we do that so that it's not... I guess one way would be to brute force it and keep re-rendering the scatter plot layer. Although I'm sure there's a better way. What is the screen grid layer? Oh, that looks cool. Okay. Polygon layer. Point cloud layer. What? No idea what that's about. Path layer. Line layer, icon layer. Okay, icon layer is what we need. Then hexagon layer does that. Grid layer, GeoJSON layer, contour, arc. Okay, so the icon layer is what we're after. Let's change that. So let's use the icon layer and make airplane icons. These are icons at given coordinates. So icon layer, and here we say icon layer, and ID is airplanes, data is this, blah, pickable false, icon atlas, icon mapping, atlas image URL or texture. Okay, so now we need an atlas icon, whatever that is, for atlas image URL for an airplane. Atlas image URL airplane. I have no idea what that is. No, that's not good. What is this? Where was I? So WebGL images icon atlas PNG. So it's just a PNG. Okay, we can do that. So let's see, where do they have this? WebGL images might work if we, because this is a live example. You can see that images icon. Aha. So it's a black thing with an airplane. So let's see, airplane icon. Or maybe we can make one ourselves. That looks cool, that looks cool. Let's use that guy. Free airplane PNG icon, perfect. So open that thing. Where'd it go? But it would be nice if it was vertical, or like, okay, let's do this first. So download the icon, perfect. Save image as, we put it in, let's see, random coding, WebGL, where are you? It should be down here. No, not WebRTC. WebGL airplane map, source airplane icon.jpg. Why is it no PNG? Fine, airplane icon minus JPEG, and we say here import airplane from / airplane icon.jpg, like that, and where was that GL stuff? So icon layer, icon atlas, icon atlas is airplane, icon mapping, we're gonna call this the airplane, which is going to go from x of 0 to y of 0, width of, how wide is this thing? Why is my computer slow right now? Yeah, I probably know why. So WebGL airplanes map source, where's the size? Can anyone see the sizing, the size info? I can't. Inspector, so 512 times 512. Width 512, height 512. So I'm assuming what this is basically defining a sprite. Anchor Y, we are going to, what does the anchor Y do? Icon mapping, anchor X, horizontal position of icon anchor, default half width. Okay, we want it to be at, is treated as a transparency mask. If true, user defined color is applied. If false, pixel color from the image is applied. Alright, so we got that. Size scale 15, whatever that means. Get position is the same as before. We don't need the color, and we don't need get radius. So let's see what happens now. Now where are my icons? So it is not working. What am I doing wrong? I am forgetting something, aren't I? Get icon. So get icon, D is airplane. So we're basically telling it which one to use. Yay, little airplanes everywhere. Wonderful. And now they're gonna be moving. Cool. Now let's see if we can rotate them. So rotate icon P, get position, get icon, get size, get color, get angle. The rotating angle of each object in degrees. So if we say get angle, and basically first we want to move them from being diagonal to being pointing straight up, because that will help. So let's see if that worked. Aha, the other 45. Cool. So now they're all vertical. We're going to use the information from data to rotate them the correct direction. So get angle plus math pi radians. I always forget this formula. Radians to degrees 180 divided by pi times radians. So plus d dot, what did we say it was? True track, d dot true track times 180 divided by math pi. Let's see if they're all rotated in different directions now. They are! Yay! Okay, so we now have little airplanes that are positioned in the direction that they are supposed to be positioned in. We can make them a little bigger, I think. So size scale 25 maybe. That is probably too big. Let's do 20. So size scale 20. No? I think it didn't refresh. There we go. So now we have airplanes that are actually turned in the direction that they're turning. The next step is to fake their movement while we fetch data, because right now data is because we're only getting data every 10 seconds, we have to interpolate their positions in between. How do we do that? See, they're moving just very slowly. So we know their velocity, and we know the direction they're moving in. Let's see. Velocity, geo-altitude, squawk. How do I do that? Time for another commit, actually. So git status, git add source, git commit -a-m, airplane icons rotated to airplane directions. Got that. Now let's see, does D3 give us some nice tools we can use for this? D3. D3 wiki API reference. Interesting. Let's see, geographies, path, spherical math. That's what we need. Okay, geo area, geo bound, centroid distance returns the great arc distance in radians between the 2 points A and B. Geo length, geo interpolate returns an interpolator function given 2 points A and B. Each point must be specified as a 2-element array in degrees. The returned interpolator function takes a single argument. Geo contains okay, so we do need the interpolator. That's gonna help. And how do we get the second point is what I'm wondering. Let's try. So here we're gonna do interpolate pos is going to be D3 geo interpolate, which starts at D6 and D5, D6, latitude, longitude, latitude, longitude, latitude, D5, D6. Now, how do we get the next one? So in 10 seconds, if they're moving by 10 meters, so velocity is in integers per second, right? Velocity over ground in meters per second. So we know how many meters they're moving. How do we know what? Yeah. So if we have this position, how do we add meters to it? Geolocation velocity next point calculation. How to use direction, angle, and speed to calculate next times. Perfect. Okay, so we're gonna say next pos of D5, D6, latitude, longitude, longitude, latitude. Oh, so we were actually using these guys wrong. It's latitude, longitude, not the other way around. Alright, so the longitude, latitude, I don't know. Let's keep with the, I never know which one is latitude. What does latitude tell us? It geographically specifies the north-south. So latitude is the vertical position. Okay, 5, 6, 5, 6, and speed is d9, and the angle is d10. Right? No. Okay, next pause. Bam. Next position. So we're gonna now define next position. Function next position takes longitude, latitude, velocity, and angle, and returns. Perfect. Wonderful. TC is the radial bearing. Cool. So we're gonna actually copy paste this. See, Stack Overflow driven development. Perfect. Taken from blah, like that, and we save this as destination point.js, and we export default function destination point. Export default function destination point. We don't need that, and we say import destination point from /destination point, because I really don't want to implement that again, except now we're getting latitude, longitude, and 5 is longitude, 6 is latitude. So destination point 6, 5. Okay, so what this is going to give us is the ability to calculate current position based on the interpolator. So now we need to re-render this 60 times per second and use the interpolator to do stuff. Okay, so we're gonna have state with current frame is 0, and we're gonna essentially use the game loop approach. So fetch data, which starts D3 timer. Is it D3 timer interval? Is D3 interval? Why do I always forget this shit? Interval, time intervals, timer. Yep. Alright, so D3 timer fetch data is going to stop the timer, so we're gonna say timer equals D3 timer, or here if this dot timer, then we stop. No, actually we never stop the thing. We're just gonna say this dot timer on set state. Actually this set state here after state is done, when it's set up, we're gonna say this dot start animation, and here start animation equals a function that does stuff. If this dot timer, then we say this dot timer dot stop. Otherwise we say this dot timer equals d3 timer that runs this dot game loop animation step, like that. And we're gonna have animation step is a method that is going to do stuff. So animation step, actually let's look at this while we're doing it, because why not? It's right there. So animation step, on every animation step we now have to go through all of our state and update positions. Yep. So we're gonna say let airplanes equals this dot state, like that. Got the airplanes. Then we say airplanes equals airplanes dot map, and we need to have this dot timer stop. What else do we need? We need the current animation step here. So airplane timer stop, this dot timer, this dot animation step, current step equals 0. Airplanes map, we go through D and we say what do we return? We return the entire D copied. That's probably gonna end up being a bit slow, but and we say it's been a while since I've done any React Native, but I am going to be doing more freelance work coming in the following year. I wouldn't bet on myself being the best option for React Native right now, because it's been a really long... I basically haven't touched React Native since I've been doing the Shouten blogs last year. So my knowledge might be rusty, and from what I remember, React Native moves pretty fast. But shoot me an email and we can see if there's a fit there, and if I can help you. And my email, or like Twitter DM or hi@swizzets.com is probably a good way to email me. So for this destination, GeoInterpolate is going to do what? Let's see. GeoInterpolate georotation returns longitude and latitude. So let's see. So we have that, and we say const pos equals d dot interpolate pos of what's the... Let's assume that this is running at 60 frames per second and we have 10 seconds. So we are now on the this dot, what is it? What did we say? Current step. So current step is null, timer is null. How do I interact with this? Okay. Um, okay, so where was I? Const interpolate pos. We need to get the current step divided by how many steps we think there's going to be. So we know that the steps per fetch equals, or let's call it current frames per fetch, because that's going to be easier. So we have 10 times 60, so that's our 10 times 60 FPS, 10-second intervals. Cool. This start animation. So we start animation and we set timeout this dot fetch data with 10 times 1000, like that. This timer stops the timer, sets current frame to 0. Then we have this dot animation frame, airplanes interpolate pause, and we say this dot current frame divided by this dot frames per fetch. That's the current position, and we return a new copied D, and we say longitude is pos of longitude latitude, and we return longitude and latitude, like that. What do you mean? Airplanes is used right here. And we say this set state airplanes. And let's see if my computer is beefy enough to manage doing that. Okay. So I can't really tell if these guys are moving. Oh, that's what's going wrong. So on every step of the animation, we have to say this dot current frame plus equals 1. Okay, so that's not working. Well, they're animating, right? Kind of in weird waves. Interesting. I wonder where they're flocking. They're going like birds. Interesting. Okay, so the destination point isn't working. What if we say 5 and 6 here? Yes, no, I know there's no program to debug. 5 and 6. No, they're not moving in the right directions at all. So 6 and 5, and it also looks like they're all moving in the same direction, which is kind of weird. Yeah, it's a cool effect, but it's wrong. And then every 10 seconds it updates. Okay, so we are passing in latitude. Okay, let's just change that. So 5. So it gets longitude, latitude. And let's see, D3 interpolator gets longitude, latitude, or georotation, where are you? Geointerpolate, longitude, latitude. So longitude, latitude, longitude, latitude, velocity, and the orientation. So destination point needs to take longitude, latitude, distance traveled in meters, initial bearing in degrees from north. So this has to be in degrees, that's what's going wrong. It's also going to travel, frames per fetch is fetch every, this dot fetch every s, fetch every s, every seconds equals 10, fetch every seconds, and here we say this dot fetch every seconds. Great, so destination point, if it's traveling some meters per second, we have to say this dot fetch every seconds, and we have to translate radians to degrees, which we do like this, times 180 divided by pi. Let's see what happens now. That is not working. Our destination point as latitude, longitude. That's what's going wrong. So we need to longitude, latitude, right? I'm pretty sure latitude is the vertical one, right? Yeah, so longitude, latitude. So here we gotta invert these guys. I think that's working now. No? Are they constantly moving? They are. Look! It moves. But it moves more than it's supposed to. Still pretty cool though. Okay, so that's working now. We get, that looks realistic, right? See, the plane is flying, but it's flying in the wrong direction. Why are they flying in the wrong direction? Now, the problem here is that I don't know if the plane is flying in the wrong direction or if it's turned in the wrong direction. Okay, so here's how I'm gonna change that. So true track is decimal degrees clockwise from north can be null. So if that's going clockwise, I believe this is using it in the exact opposite direction. To radians to degrees. So what happens if I put a minus here? Let's go look at an airplane here. Yep, now it's working. Look, well, mostly working. It's flying in the same direction as it's turned, and in theory we should see it fly smooth, but then it jumps. So I think we're using true track wrong, because it looks like it's flying there, but it's actually flying there. So this was right, and this here was wrong. Now let's see. Fine. Let's look at this guy. Are you a parked airplane? No, you're just a very slow airplane. So I think this is working now. Yeah, mostly. There seems to be some jumping around, but that's okay. Cool. Okay, let's go look at Los Angeles airport. These are all pretty slow airplanes, aren't they? Let's see what can we find that's more interesting. What's bothering me is that they're jumping. They shouldn't be jumping like that. See, they should be constantly moving. They are kinda constantly moving, but they're also jumping, which probably means we aren't actually rendering at 45 frames at 60 frames per second. How can we measure frames per second? So let's see. Git status, git add source, git commit -a -m, constantly moving airplanes with interpolators. How can we measure the frame rate? Is there a way to get that? Okay, optimizing updates, tips and tricks. Okay. Wow, 10 viewers, nice. So what I'm trying to figure out is that's cool. Okay, that's complicated. So what I'm trying to figure out is how to make it so that we know, how do we know how many frames per second we have? Because look at this. If we change frames per fetch to be 30 frames per second, these should now be moving more. Though they aren't really moving, are they? Is it moving? It is moving. Look at that. So it's flying to the left, but it's actually flying the exact opposite. So we do need those minuses. So minus here and a not minus here. Let's try that again. Let's find this airplane here. I think that was the same one we were looking at before. It's flying up and jumping down. I am very confused right now. What if we don't do any minusing anywhere? I'm clearly not very proficient at angles and stuff. So now it looks like it's flying in a completely weird direction. So let's look at this one here. Yeah, that's definitely going in the opposite direction than when it jumps, than where it renders when it jumps, isn't it? Okay, so that's clockwise. Which direction is this expecting it? In degrees from north, but which direction in degrees from north? Angular distance in radians, bearing. I'm gonna do this. Okay, where are you moving, airplane? Yeah, you know what? Let's try this. We know this is in radians, so we, with small modifications to fit our use case. So no changing it to radians. Great, so because it's already a radian, then this is like some mathematics that I'm not fluent in, but it should be doing what it's supposed to. one thing is that I'm never sure how angles are counted. Here, where we say, okay, so if we adding 45, so it was turned this way, adding 45 to it turned it backwards, which means that if true track is radians from north in a clockwise direction, that means it's in the opposite direction than what people usually use. So let's try what happens when we do that. So it's now flying down to the left. Let's see if it jumps. It jumps. Okay, now let's see what happens with this airplane. And I think I'm just gonna give up really soon and go have some food or something, because I'm clearly failing at life right now. Okay, so it's moving to the right and jumping to the left. Why is that happening? And why is it so impossible? Like, whatever I do, it's not right. Okay, last attempt. Flying over Yosemite, going down. Let's see. Okay, I don't get it. But whatever. So something somewhere is wrong, and I'm gonna have to let somebody else tell me why. Why are there so many planes in this circle here? I have a feeling this is a bug, or like planes that don't have info. Let's see, Europe is absolutely covered in airplanes. What's flying over Slovenia right now? Only one airplane. Look, when you zoom in, it looks pretty cool. It's just that it's jumping to a different location when it updates. Yeah, I have no idea what's wrong, and I'm going to stop working on this right now. I think we achieved the original goal that we had, which was updating these planes, or like drawing a bunch of WebGL planes on a map. Cool. So thanks everyone for watching. I'm gonna stop streaming right now, and we will, I have to go do some actual work, but I will make sure there's a write-up about this up on ReactVizHoliday tomorrow morning. So thanks for watching, everyone. I hope it was as entertaining for you as it was for me, but I think we got something pretty cool done. There's obviously a bunch of ways we could make it even better,